Hello students, in today class we will study about influence on instruction sets. Okay, so some instructions are much better suited to pipeline execution than other instructions. Okay, but some are not. For example, instructions that have side effects which can lead to undesirable data dependencies. Okay, basically, so these type of instructions are not suit for the pipeline execution. Okay, so the machine instructions are influenced by basically two things. One is our addressing mode, and so one is addressing modes and another one is condition code flags. Okay, so these are the conditions which influences the machine instructions. Okay, so first we will study about addressing modes, how the addressing modes influence the instructions, machine instructions basically. Okay, for creating the side effects and generating the data dependencies. Okay, so we know about different addressing modes like our index addressing mode, indirect, direct, auto increment, auto decrement, many more. Okay, so basically addressing modes is a thing which provides the means for assessing a very variety of data structures simply and efficiently. Okay, so it uses more number of data structures in the more efficient way. Okay, so let me write it. Okay, so it should provide for assessing different types of data structures. Okay, so some addressing modes are like our indirect, direct, auto increment, auto decrement, etc. Okay, so relative, register, indirect, register, direct, index, many types of addressing modes are there. Okay, we already studied it in the previous classes. So many processors, what they do, they combine multiple number of addressing modes in a single instructions to increase the flexibility. Okay, to increase the flexibility of their instruction sets. Okay, so they are combining multiple or various types of addressing modes. Okay, so basically there are two types of addressing modes, one is complex and one is simple. So in the complex addressing modes, which uses various types of addressing modes, okay, such as those involving double indexing or auto increment, auto decrement, like this. Okay, okay, so let's see about complex addressing mode. One is complex addressing mode, another one is simple addressing mode. Okay, so let's see about the side effects of addressing mode, such as auto increment or auto decrement, which we have which we have studied earlierly. in the side effects topic. Okay, so how, let's see how they causes the pipeline to stall. Okay, and another important factor is whether a given mode is likely to be used by compilers or not. We'll see about this in a next concept. Okay, so let's see about complex addressing modes and simple addressing mode, how we can define it. Okay, so first discuss about complex addressing mode. Yeah. Okay, so let's assume a simple model for assessing operands in a memory. Basically, let's take an example of load operation. Okay, for this load operation, we will use complex addressing mode concept as well as the simple addressing mode concept. Okay, so load as 2. Okay, so let's assume that this instruction will take 5 clock cycles to complete the execution. Okay, let's say it will take 5 cycles to complete its execution. Okay, but we are having a compiler which is having 4 stage pipeline, because no address computation is required. That's why the instruction can be organized to fit a 4 stage pipeline. Okay, so access to memory can take place in stage of execution. Okay, basically, so a more complex addressing mode may require several accesses to the memory to reach the named operand. Okay, so for example, take this. Okay, uh, so let me write it here that for this sorry, access to memory can take place in stage E, that means in execution stage. Okay, so for the instruction load x r1 comma r2, this one, huh? ସମ୍ବେଦନ ସମ୍ବେଦନଶୀଳ ନା କ'ଣ ଦେଇଛି? ସମ୍ବେଦନଶୀଳ ଲତା, ସମ୍ବେଦନଶୀଳ ଶୁଣୁନୁ, ସମ୍ବେଦନଶୀଳ ମାନେ ଯାହାକୁ ଛୁଇଁଲେ ସେ ପ୍ରତିକ୍ରିୟା, ଆମେ ପ୍ରତିକ୍ରିୟା ପ୍ରକାଶ କରୁ। ଆମକୁ କୁହାହବ ସମ୍ବେଦନଶୀଳ ଅଙ୍ଗ, ତତେ କୁହାହବ ତୋ ବେକ, ତତେ ଛୁଇଁଦେଲେ ସଲସଲ ଲାଗେ ନା, ସାଙ୍ଗେ ସାଙ୍ଗେ ଏମିତି ଜାକି ହେଇଯାଉ, ଜାକି ହେଇଯାଉ ନା ନାହିଁ, ହାତକୁ ଛୁଇଁଲେ ଜାକି ହଉ, ବେକକୁ ଛୁଇଁଲେ ଜାକି ହେଇଯାଉ, ସେମିତି ସମ୍ବେଦନଶୀଳ ଆମର ଏଇଟା ଯାଇ ଜାଗାଟା ହେଉଛି ଆମର ସମ୍ବେଦନଶୀଳ ଜାଗା। ସେମିତି କେଉଁଟା ହବ, କେଉଁଟା ହବ ତୁ କହୁନୁ, କେଉଁଟା କହ? ଛୁଇଁଲେ ପ୍ରତିକ୍ରିୟା ପ୍ରକାଶ କେଉଁଟା କରିବ? କ'ଣ ଲେଖ, ହଁ ଲେଖୁନୁ। Okay, okay, so in this instruction x is the offset value which is required to generating the effective address basically. Okay, which I have already known about this. So it is computed, it is started computed in the cycle 3. Okay, so in the cycle 3 it computing the address. Okay, so the processor needs to access memory twice. Okay, basically it needs twice to access memory, because in the first access it wants to read the location, okay, which is in the clock cycle 4, it reads the location. Okay, then okay, then first it will count the location, what is the location, then after the counting it is going for the read. This is the counting part and this is the read part. Okay, after read it will fetch which, what is the content. Okay, as we know, this for content we are enclosing that with the parenthesis, okay, or square braces, basically square braces. So this is for computing the address, computing address, and it is read location. Okay, so after reading the location, okay, again it will read the location for fetching. So read location will be performed twice, that is a memory access is needed for twice. Okay, for 4 and 5 clock cycle. Okay, so let's, okay, so let's assume that if we are having another instruction in which R2 is the source operand, here R2 is destination operand, we are loading the content of this. If we like this, we will content of this into R2. Okay, so by adding, that means we have to add x plus R1. Okay, that is offset value with R1, whichever the address, it will be added with this, and then this will be loaded into the R2 value, like R2 register. Okay, so if in the next instruction, in the next instruction R2 is the source operand, then data dependency occurs and it will be stalled for okay, for 3 clock cycles basically. Okay, okay, which can be reduced to 2 clock cycle. Okay, here I am already reducing 2 clock cycles by using operand forwarding concept. Operand forwarding concept we have already discussed about this in the previous lectures. Okay, what do you mean by operand forwarding? So by operand forwarding we can reduce it into 2 clock cycles, but minimum will be 2. We cannot reduce than that. Okay, so to implement same load operation using only simple addressing mode, it will require several instructions. That means in it we're combining multiple addressing modes. Okay, here we are computing the address, the effective address basically. We are directly using the registers. Okay, here we are reading the location. Okay, so we are performing multiple operations in a single instruction, so that's why it is called as complex addressing modes. But if we'll implement the same thing in the simple addressing mode, then we'll divide that instruction into small instructions. Okay, so what are the instructions? Let first we'll add into R1, then R2. Okay, as we know that we have to add this offset value into the R1, so here I am taking it as a what, immediate value, immediate addressing mode. Here only immediate addressing mode we are using, no complex. Okay, so load R2 content into R2, this. Okay, so this add is what it will do, it will do R2 R1. Okay, and the two load instructions fetch the address and then the operand from the memory. Okay, it will fetch the address. Okay, it will what it will do, it will fetch the operand from memory. operand. Okay, that's why we're using two read location. Okay, first for operand reading, second for address reading. Okay, so that's why we're using two load operations. The syntax is same, but the operation is different. So these sequence of instructions take exactly the same number of clock cycle, 5 clock cycles as the original. So single load operation like this. Okay, okay, but here we are not stalling any instruction. Okay, when it will for the next instruction, it is already in the memory, so it can easily execute this instruction. Okay, so but here in the complex addressing mode we have to stall for 2 clock cycle, but in the simple addressing mode we are not stalling the instruction which is the next instruction. Okay, as we are dividing this, and for this we are using different pipelines. Okay, that's why we are not going to wait for some operands. Okay, so but main problem is that in a pipeline processor, complex addressing mode that involve several accesses to the memory actually do not necessarily lead to the faster execution. But the main advantages of this complex addressing mode, the main advantages of complex addressing mode is that they reduce the number of instructions. Okay. So for complex addressing mode, till it reduce the number of instructions. Okay, it will reduce the number of instructions which is needed to perform a given task, and thereby to reduce the program space also. Number of instructions, then reduce program space. Okay, it will also reduce the program space. Okay, but only disadvantages is that their long execution time causes the pipeline to stall. So what is the disadvantages? These are the advantages, and what is the disadvantages? This is stall. Okay, which reduces its effectiveness basically. Thus they require more complex hardware to decode and execute them. So the instructions of modern processor are designed to take maximum advantages of pipeline hardware. We are designing an effective hardware for this type of execution. So the addressing mode used in modern processors have some features like only load and store instruction access memory operands. The addressing modes used to not have side effects. Okay, like this. Okay, so let me write it here. Okay, okay, let's discuss about the simple addressing modes advantages. Just the opposite. Okay. Its advantages is it does not stall the processes, it continuing the process. And disadvantages it increments the number of instructions and also increments the programming space. It is the two disadvantages and it is the advantages for simple addressing modes. Okay, so let me write about the addressing modes used in modern processors have some basic features. Okay, so